So where, well, first off, where is the average of the roots is going to be 10, it's going to be 5. And so we have something that kind of looks like this. Here is my function. And so the answer to the question is that the profit is maximized when x equals 5, because that's the vertex of the parabola representing the profit function. Triash, we good? Yeah. So the answer to the question is that I should raise the price 5 times, and thus I should charge $6.25. But analyzing this graph is actually kind of like fascinating and interesting. Let's see. So it's here that I make the most profit. How many widgets do I actually sell here per day?
55.
55. So I sell 55 widgets, and I charge $6.25 each for them. What is the interpretation of what happens as I move like along this curve? What's going on? Yeah. I'm raising the price and I'm selling fewer widgets and I'm making less profit. What happens like over here?
Shouldn't it switch to linear?
I don't know. Wait, we're going to talk about this. What happens at 16? Yeah, now how many widgets am I, how much am I charging per widget?
A lot.
A lot? Can I get an answer?
No one buys.
16 times 20 was like 4. So I'm charging $9, right? So I'm charging $9 per widget. Still seems like a reasonable price. How many widgets am I selling?
0.
Oh yeah, and so I'm selling 0 sales. So 0 sales. So hence my profit is 0 because I'm selling no widgets. All right, what happens now?
Well, like if it's reasonable, you can't get, people won't buy them for negative results, so you're not like paying people to buy them.
Yeah, but let's just interpret it literally. What's happening now is I'm charging even more money, like $10 per widget, but I'm actually like, what am I doing? I guess I'm like...
You're getting negative people to buy them.
You're buying widgets.
Selling. Yeah, you're
It should be like a
Shouldn't it be a
negative
straight line after
Your widgets are so bad.
I'm not sure what's going on. I take it back. I thought there was something cool happening. Okay, how about a -6? What's going on at -6? This one's in...
Shouldn't be linear after that.
Because it's 3x, like it costs $3.50 for every widget, nobody's still buying them, so.
I guess I'm like giving them away here though, which is why...
But you're not giving them
But
away.
you're continuously buying them.
Because you're selling them at $10, so.
Apparently people don't want to buy
So
cheap
wouldn't it be like
widgets.
linear?
It should
do
be
that.
like a free.
Okay, good. Over here, now what if it's -6? What does that mean? How much am I charging per widget? $3.50. So now, how many am I selling?
What?
I'm selling a lot. I'm selling like,
110.
yeah, I'm selling 110 widgets per day. Because, right, as I lower the price, I'm actually selling more widgets, right? Selling more widgets. So I'm selling a lot of widgets here, but I'm selling them for the exact price which it costs to produce them. Thus, I have a profit of 0. Okay, I don't know. That was kind of interesting. All right, other hard problems from this packet. I thought there were like a lot, actually. Number 10, you prove some fact algebraically, which actually just proves that -18 is the absolute minimum. Yeah, George, you're pretty smart, George. What else? Number 11, you're proving that when A is less than B, f of A is less than f of B. In other words, what have you proved for this particular function? It's increasing, yeah. Who needs calculus? I don't need calculus to prove a function's increasing. As long as the function's easy enough, like a quadratic, I can actually prove it rigorously by demonstrating this inequality. Are you with me? No, Kim?
Sort of, yeah.
Sort of. Yeah, good. You should come to lunch like every single day from now till forever. Here we have a bunch of things, and we have a bunch of things, and there's like a bunch of things. Yeah, good. Oh, number 12. 18, 12. I think you can do 12 now, right? It's factor
They're
theorem.
still separate. But they're
Factor theorem. Do it right now.
Well, they're not separate squares if they
Actually, the
share.
simplest thing to do is just to do the synthetic division, right? Just synthetic division in that -2, synthetic division in that 3. You do the factor theorem, and then you just have a quadratic, and then it's just factors. Let's do one more problem from this. 18.
He thought the squares were connected, so they're like sharing the area of one of
No,
them.
I don't want to do 18. You guys figure it out. Basically, what you end up with is, for 18, what you end up with is, just make one big square, right? And the worst thing to do is make two squares. that are the same size. Yeah, that says something deep about life, I feel like. about sharing and things like that. All right, number 20 was pretty hard. Similar triangles. Pre-Calc A was doing this problem like a few weeks ago. I don't know if any of you saw them. They were all in math, all freaking out. Like a month ago.
Oh, yeah, I remember that.
Yep.
That was funny.
I think I'm just going to give you guys another chance to finish. Can I collect this? I'm just going to collect this packet later. Alright. Later I mean Friday. Hold on, I want to do like 5 more things. But I have, 13 minutes? I guess I should just go over the quiz.
Yeah.
Should we just do that next class too? Should we do right now?
Now.
Well,
Now.
what if you put it
You
on
can
now?
just hold up
Okay.
everybody who isn't here's quiz up to the camera.
Oh, yeah. Oh, yeah.
One at a time, and say like, if this is not your quiz, don't watch.
Okay.
See how trustworthy you are.
Exactly.
So, come get your quiz when I call your name. Jason. Anish.
I'm pretty sure I got it.
Reed.
Okay, that works too.
Kinzo. Sahil. Armand.
That's how it
George.
Ankita.
You don't want that to be on YouTube.
That's it.
Shreya.
Why is this wrong?
Armand.
Nisha.
Wait.
Oh, because it's too
Theo. Ryan.
I didn't notice the negative signs canceled out.
So what do you get?
I know, I
Denzel.
got a negative.
So, oh my
Noken.
god, why is it worth 4 points?
George.
Absolutely fail.
It's like right there.
Toma.
That would be 10 pi over 6, not pi over 12.
Is that everybody?
They're the same.
Yeah, you too. I just called your name.
I wasn't listening.
Alright, can I just say that this quiz was like kind of easy, I thought.
Yes,
Very, very straightforward. You just needed to know some basic facts about
Misinterpreted the first part.
trig identity. There was one problem which required a little bit of intelligence and ingenuity. Otherwise, usually it's just, okay. So, I mean, I can probably do this whole quiz in like 5 minutes. It helps that I just know all the answers. But like, still, tan of 13 pi over 12. Okay, the first thing to do, what does 13 pi over 12 look like? It looks like this, right? Yeah.
Yes.
It's like a little bit more than pi. What?
I lost 10 more points than I should have.
Oh, that's bad.
Yeah.
Saying I added wrong?
Mr.
Yep.
This has happened in the past.
Easily fixed. Easily fixed, Shriyash. Wacha. Okay, so tan 13 pi over 12. That's so basically I guess that's just the same thing as pi over 12. So I just wanted to see if maybe you noticed that, right? Then it's just doesn't really make it any particularly easier, but I don't know, kind of makes it easier. The definitely fastest way to do this is just to know that this is tan of pi over 6 over 2, and to use a half angle identity. What is the half angle identity for tan? I just make the picture every single time in my head. I kind of want my denominator to be pretty, so I guess I'm going to use the this one version. So that's x over 2, and that's x over 2. Everyone with me? So that would be 1 minus cosine x over sine x. So this is 1 minus cosine pi over 6 over sine pi over 6. So that's 1 minus root 3 over 2 over 1/2. And therefore the answer is 2 minus root 3. Time to completion, 1 minute. What else? Number 2 was actually the one problem that was actually a little bit hard. 8 sine x cosine 2x plus root 3 equals 0. Alright, here, when you see sine x and cosine x being multiplied by each other, it's alarm bells should be going off. It's why we practice the identities forever and ever and ever and ever and ever. That's just basically sine 2x, right? So if I replace this, so this is basically 4 times sine 2x, cosine 2x, plus root 3. And now, Again, right? This is just another 2, and now this is like sine 4x equals negative root 3. So we just have sine 4x equals negative root 3 over 2. I really feel that you guys like should have seen that. If you didn't get that, I'm sorry, but you need to see that kind of stuff. That's why we do the identities over and over and over and over again. So we just know them, so we have opportunities to apply them when needed. Like here. Okay. Anyway, at this point you just finish it off. When is sine negative root 3 over 2? Sine will be negative root 3 over 2 at however you like to do it. 4 pi over 3 or 5 pi over 3 plus 2k pi plus 2k pi. So I'm going to erase the backboard while I'm talking. So what I get is that x is pi over 3 plus k pi over 2 and 5 pi over 12 plus k pi over 2. Yeah?
Yeah.
Okay, good. Number 3. Number 3 is also very straightforward problem. 2 cosecant squared x plus 5 cosecant x equals 12 minus 4 cosecant squared x. Don't be afraid of cosecant and cotangent. They are friends. Since they are friends, I need to either rewrite everything in terms of cosecant or everything in terms of cotangent. What is the correct choice?
Cosecant.
Cosecant, because I have a linear cosecant factor. So what is cosecant? Cosecant squared is cotangent squared plus 1. So cotangent squared, I guess, would be cosecant squared minus 1. So this becomes 2 cosecant squared x minus 1 plus 5 cosecant x equals 12 minus 4 cosecant squared x. Alright, so that was really all the hard work. I now have it as quadratic in cosecant squared, so I just like do it. I guess that's like 6 cosecant squared x plus 5 cosecant x, and then like what's left? Minus 14? It has to factor, better factor, otherwise I'm in big trouble. But this is the fake world of math class, so probably will. And looking for a difference of 5, wait a second. Oh yeah, 20, no, what? 12 and 7, yep, bam, bam. So I get 6x7, or rather 6 cosecant x 7 and cosecant x2, and then that's like plus 12 minus 7, everything's looking good. So what I end up with is cosecant x equals 7/6, and cosecant x equals -2. So I like to write this as sine. Sine is 6/7, and sine x is -1/2, and now it's just a matter of like finishing it off. When is sine -1/2? At negative pi over 6 and 5 pi over 6 plus 2k pi plus 2k pi. Did I mess this
That's
up?
the same
Yeah,
thing.
7. Sorry, it should be 7. Negative pi over 6 is 7 pi over 6. We'll just do whatever. Okay, good. And then when is sine x 6/7? Well, there's going to be 2 times. There's going to be there's going to be arc sine 6/7, which is guaranteed to be a first quadrant angle, plus 2k pi. That's going to be whenever the sine is 6/7. That point is going to be something, comma, 6/7. That's one answer, but then there's also the other one, when the sine is 6/7. And what is that? It's pi minus arc sine 6/7. Como, you can't say 3 pi.
Yeah, I know.
You see why that's wrong now?
Yes.
Yeah, good. Okay, good. How much time do I have left? Until 50. That's when the bell's gonna ring. Yeah, good. I have 5 minutes. Just enough time to finish the rest of this quiz. Actually, page 2, I feel like I just don't even need to go over. Basically, it's just a matter of, can you draw pictures properly? If u is pi minus arc sine -3/5, then I just have to be smart enough to correctly draw that. You have 2 options. You can interpret it literally as is. Arc sine -3/5 will be like this angle, such that that's -3 and 4 and 5. And then I have to do pi minus that. So what is pi minus that? That's like pi, and then I'm subtracting this negative angle, which means I'm adding the positive version of it, right? So therefore, you get this. And pretty much assuming you draw the triangle correctly, you're good to go. Is everyone with me? This is u. Another option is to know that arcsine is an odd function, so you can just take out the negative and just make it plus. Yeah? once you have the picture, then you make the other picture arc secant negative 13/5. You have to know that that's the second quadrangle whose secant is negative 13/5, so that has to be that, and you triple out and you're pretty much done. Now that I have u and v, I just apply, just basically, do you know your identities? Can you add and multiply fractions? That's the whole rest of the page. Okay, good. Number 3, page 3 rather, you have to prove an identity. It's easier to just move the whole tripod, Daniel Zoo, than it is to actually try to rotate the camera. But I have to prove, I don't even feel like I need to, this identity is, man, sorry to be mean. This identity is easy. 1 plus sine 2x over 1 plus cosine 2x equals 1/2 1 plus tan x squared. Okay, how do we do this? Kind of just do it, right? What is 1 plus sine 2x? Well, I guess it's just 1 plus 2 sine x cosine x. And what's going on down here? Well, cosine 2x, well that's 2 cosine squared x minus 1, which works out nicely because like the negatives kill each other. And then you have a lot of options now, I guess. But
Separate
one
the
thing
fraction.
you could do is like, I don't know,
Separate the fraction.
separate the fractions, yeah. So I have 1 over 2 cosine squared x, but here I have plus, or maybe I'll just take the 2 out entirely, since I know I have to do that anyway. So I get 1/2. These 1's die, that 2 goes out, and then it's just 1 over cosine squared plus sine cosine over cosine squared is just sine over cosine. So now I'm pretty much here, and then, well that's just tan plus secant squared, right? Did I do something wrong? I feel like I did something wrong. Tan plus secant squared, no that's fine.
Yeah, that's right.
Yeah, so what I have is 1/2, this is secant squared x, and then this is just tan x. No, I think it did.
But
Oh, yeah, because
it's
there's
2 cos x, so it should be like if you should
Yeah.
do
Oh yeah,
it
because
like
that 2 is still there. I'm like
Yeah.
kind of skipping too many steps. The 2 is still there, because all I did was I pulled that 2 out of the denominator, but that 2 is still there. So I have 1 over cosine squared plus 2 sine x cosine x over cosine squared. Everyone with me now? Okay, well this is
fun to make
tan
a
squared
black
x
thing
plus
for it.
1 plus 2 tan x, and it's 1/2 of that, and that of course just is tan x plus 1 squared, 1/2 of that. That's one way to do it. You could also go the other way. There are lots of different ways, but they all boil down to more or less just doing a couple trig identities and it just like happens. And then the last one, tan of 2 arc cosine negative 7/25. Again, you just kind of do it, right? What is arc cosine negative 7/25? Well, it's going to be a second quadrangle, so I draw it. I have just memorized a certain number of triples, like 7, 24, 25, as we talked about earlier. So that is a picture of arc cosine negative 7/25. I call this A, and so what I'm looking for is tan 2A. What is tan 2A? Well, there's a formula for that. It's like 2 tan A over 1 minus tan squared A. And now I just crank it out, right? This is 2 tan A is 24/7 and over 1 minus 24/7 squared, and then you just get like math answer. Alright, those of you who didn't do well on this quiz, like what happened?
I would think.
There was a lot of time on this quiz, I thought. It was like way more time than you would expect on the corresponding test. The quiz was, I gave you like, I don't know, over a half an hour, I think. Let's turn this up.